Hello, and thanks for your interest in our fact paper, AI Opacity and Explainability in Tort Litigation. In this paper, we consider the challenges that you would face if you are harmed by an opaque AI system and tried to sue the manufacturer or developer in civil court, and how explainable AI might be of use in overcoming these challenges. AI explanations are suited to different end goals, and the key contribution of our paper is to argue that some specific types of civil litigation will require explanations that align well with existing explainable AI methods. So it's well known that AI systems can be opaque. We find the taxonomy of opacity sources by Jenna Burrell and others helpful, which includes intentional secrecy, technical illiteracy, non-intuitiveness, and inherent inscrutability. In addition, we also consider the source of AI opacity, which is inadequate documentation. We argue that courts have the means to solve or mitigate some of these problems, and we illustrate this point by discussing a recent Australian court case, ACCC versus Trivago. In this case, a combination of controlled system access under discovery and disclosure orders, well-managed expert evidence, and some clever reverse engineering to produce an explainable proxy model allowed the Australian Competition and Consumer Commission to successfully sue the developer of an AI system for deceptive and misleading conduct. One thing that's evident from the Trivago proceedings is that a key factor determining how a plaintiff might proceed in litigation is the kind of access that they're granted to interrogate an allegedly harmful AI system. To this end, we introduce one possible taxonomy of levels of AI model access, which consists of descriptive, query, and debugging access. So debugging access is like an all-access pass, for example, letting someone step through model execution like a developer would inside an AI company. Descriptive access, on the other hand, would be if you only had documentation about a system, or you had the details about a model's architecture, but no checkpoint file. Query access is a middle ground, where a plaintiff can submit inputs and observe system outputs, perhaps through an API or a compiled binary. Each level of AI system access will enable different types of explanation and argumentation in the context of a court case. With this framework in hand, we set about generalizing insights from the Trivago case, which was about misleading claims, to other torts or civil wrongs, such as negligence and product liability. We use an imaginary case of an autonomous vehicle accident to explore and evaluate various options for dealing with AI opacity. These range from litigation strategies that sidestep opacity altogether, like suing for failing to give suitable safety warnings, to approaches that rely on drawing inferences from limited access to the model, for example, inferring fault from the existence of opacity in and of itself, to more involved approaches that build a case from detailed empirical and counterfactual explanations. One exciting thing that we noticed in our work is that the common legal test for attributing causal responsibility for civil wrongs asks whether, on the balance of probabilities, harm would have happened but for the unlawful conduct. We argue in our paper that this legal language actually invites the application of statistical and computational XAI methods, giving cause for hope when AI systems inevitably cause harm. We hope that legislators, regulators, litigants, and computer scientists find our discussion insightful, and we look forward to discussing these ideas and more with you at the conference. Thank you.